If we wanted to make a cloud entirely from scratch, we'd first need a whole fleet of jumbo jets, or several hundred hot air balloons, to haul hundreds of tons of water up to the sky. And then, somehow, we'd need to disperse all that liquid into a mist of droplets small enough to float. In short, it wouldn't be easy. And yet, our atmosphere manages to pump out one cloud after another all over the world, at altitudes of up to 20 kilometers above sea level, using water and fuel carried all the way from Earth's surface. Cumulus clouds, for example, get their start when solar energy evaporates water from oceans, plants, and soil by breaking the bonds that hold water molecules together. As the patch of air above collects moisture and heat, cooler, heavier air sinks around it, pinching it off and pushing it aloft like an invisible hot air balloon. Surprisingly, this balloon's cargo doesn't weigh it down. In fact, the more water vapor it collects before liftoff, the lighter it gets. As weird as that sounds, it's because water vapor is a gas, just like the nitrogen and oxygen that make up most of the atmosphere. Basic physics dictates that a given volume of gas has the same number of molecules regardless of what those molecules are. And water is made of H plus H plus O, which is lighter than both two N's and two O's. So warm, humid air is even more buoyant than warm, dry air. As the invisible balloon goes up, the falling pressure outside allows it to keep ballooning, which spreads out its internal heat and lowers its temperature. Eventually, the air at the top cools enough for the water vapor there to condense into droplets, which look from afar like a thin wisp of cloud. And as the rest of the balloon rises, water vapor continues to cool and condense at the same altitude, creating a flat-bottomed cloud that appears to grow upward out of nothing. What's more, as the condensing water vapor molecules bond together into liquid droplets, they release the energy they absorbed from Earth's surface when they evaporated. This heats the surrounding pocket of air, giving it lift and sucking more moist air up behind it, which cools and condenses and releases heat, which fuels lift and strengthens the updraft. Even in a small cumulus cloud, the total energy released from condensation is huge, equivalent to about 270 tons of TNT. And if the supply of water vapor is much larger, the energy released can produce stratosphere-high pillars of cloud with violent updrafts, fierce electrical storms, and grapefruit-sized hailstones. Not good weather for hot air ballooning. Hey, this is Emily from Minute Earth. This episode was brought to you in part by the web show and YouTube channel Animal Logic. Each week, Animal Logic's host Danielle Defoe takes an unblinking look at one member of the animal kingdom. And I really mean unblinking. I've been watching this show and learning about exploding pigeons, corkscrew-shaped penises, poop sprinklers, and lots of other stuff I frankly didn't even know I wanted to know. And I can say it's totally worth it. Check out Animal Logic at youtube.com/animallogic or click on the link here or in the description below. Thanks for supporting Minute Earth, Animal Logic, and keep up the great work.